Okay, so it is 10 o'clock. So we will get started with our lecture. As always, questions, feel free to put them in chat. You can message me privately or you can send them to everyone. But I'll share screen here so we can all look at the same PowerPoint. Right, there we go. Get that popped up. And all right. Hide the thumbnail. All right. So the first thing we're going to talk about today is just the idea of energy. And there's only really two types of energy in this world: kinetic or potential. So kinetic is the energy of motion, and potential is the energy that is associated with position or composition. And so you can kind of think of potential energy as stored energy or built up energy, and kinetic energy is energy actually moving. And the total energy of a system is the kinetic plus potential. One way to think about this is gasoline in a car. Because of the way the bonds are formed in gasoline, gas has a lot of potential energy. And we release that energy by lighting that gas on fire. And by lighting gas on fire, we can move pistons. And so those pistons are motion, which turn the wheels of a car, which move our car. So we take our potential energy of the gasoline and we can convert it to kinetic energy. Now, you might also think of thermal energy as well. Thermal energy is really just kinetic energy. So when people say it's hot outside, what they really mean on like a scientific level is that the air molecules are moving really fast outside, because that's how we feel heat. We feel how fast molecules are crashing into our skin. And so the faster they are crashing into us, the more kinetic energy they are giving to us when they hit us, and we feel that as heat. While if something's cold, these air molecules are moving very slowly, and so when they crash into us, we are giving heat to them. And so we feel this heat loss, and we say it's cold out because these molecules are moving very slowly. Now, there's this idea of the law of conservation and of energy. That is, energy can't be created or destroyed. It can only change forms or transfer from one object to another. And so this idea is shown in the example on this PowerPoint. And if we were in class, I would do the same example with my pen. But let's say, you have a weight at the very top of a building. The higher you put something, the more potential energy it will store, because gravity is going to want to pull that down. So if you have this weight and you release it from the building, that potential energy is going to be converted into kinetic energy. Now, gravity is pulling it down, and so it will have movement speed until it hits the ground. When it hits the ground, what's going to happen is going to cause all the atoms to vibrate very fast. That vibration is heat. So all the energy you stored up right here, it's going to dissipate into the concrete as heat. So if you could actually measure the concrete, what you would see is when that weight hit the concrete, it would heat up very, very slightly, because all the energy that was stored into that weight will be transferred to the ground when it hits the ground. So that's the law of conservation of energy practically. energy cannot be destroyed or created. The amount of energy we have in the universe is fixed. You can only change its forms or transfer it from one object to another. And when you transfer energy, we call that temperature or heat. Right. So let me get these markings off. Go to the next slide. Oh, markings are still there. Please clear all my drawings. Thank you. All right. So that's energy. Now, when we do chemistry, we're going to be doing a lot of measurements and a lot of calculations. And when you go through your day-to-day life, you do a lot of calculations and measurements anyways, even if you're not consciously aware of it. Your body's doing this all the time. Or when you go to the grocery store, you know, you're following a recipe, you need 14.5 ounces of chopped tomatoes or something like that. Now, Americans, I don't understand why we do this. We use the English system, which doesn't make sense. Like, if I want to convert feet to a mile, there's 5,280 feet in 1 mile. That's hard to memorize. What is it? What do I usually do at the grocery store? How many ounces are in a pound? There's 16 ounces in a pound. That's inconvenient. Now, what you do in science and more or less the rest of the world, they have a much better system called the metric system. The metric system is way easier to understand because they have a base unit of 10, where how many centimeters are in a meter? There are 100 centimeters in a meter. How many meters in a kilometer? There are 1,000 meters in a kilometer. How many grams in a kilogram? 1,000. So no matter what unit you're working in, grams, seconds, minutes, anything like that, as long as you know the prefixes, you can figure out the metric system. Yeah, yards, pounds are dumb. So I'm with you there. I wish America would change for the metric system, but we hate new stuff, so that's never going to happen. But we're in a science class, so we're going to learn the metric system. And if you already know the metric system, fantastic. What we need to know for this class are the prefixes I have by the yellow boxes. Now, I'll show you how to use this chart, right? So what this chart is saying is, let's say we are in, let's just say grams. What this chart is, it's saying, for example, 1 kilogram equals 1,000 grams. These are the base unit you're working in, be it grams, seconds, whatever. So 1 megagram is 1 million grams. And these are our conversions. So anytime you see a K, an M, a D, a C, M, or the Greek letter mu, we want to know how to convert between these easily. Now, what you can also see on this right-hand side are the powers of 10. Basically, it's the same thing. So 1,000 grams equals 10 to the power of 3 grams. It's just scientific notation, because if I was actually writing down these numbers, instead of writing, 0.000001, it's way easier to write 10 to the minus 6 grams. So when we are doing these to begin with, I recommend, have this chart open until you get a good feel for how to do conversions. Flashcards could also help for these conversions. But so on test 1, don't be surprised if I say, you have 1,000, or let's just say 520 kilograms. How many milligrams is that? Do that conversion for me. That's the type of question you might expect for these conversions. And so what we're going to do is we're actually going to do some practice on these conversions. And I just realized I don't have my book with all the answers in it. So instead of doing calculations for you off the top of my head, let me go grab that 1 second. All right. go through all my papers. Here we go. All right. I have the right sheet in front of me now. So we're going to do conversions. We're going to do practice with conversions. And I will do A and E for you to show you my method of how to do conversions. So I am going to, let me get the whiteboard out. So I'm going to stop the screen share, and I'm going to get the whiteboard up so I can have more space to work with. All right, so here we go. So our first conversion is I want to convert 515 kilometers to decameters. I want to know what is that conversion. And on our chart, if you don't have the chart up, I'll write down what you need to do, right? So we know from our chart, 1 kilometer is 1,000 meters. And we also know from our chart that 1 decameter is 0.1 meters. All right. So we have all the information we need to do this conversion. And what I use is I call it the train track methods. So what I'm going to do is I'm going to start with the number I want to convert from. And then once you have your number, you write a track like this. And I want to do my first conversion. My first conversion is going to be from kilometers to meters. And the way this method works is that if you have a unit at the top, if you have the same unit at the bottom, they cancel each other out. So for example, I put 1 kilometer is equal to 1,000 meters, all right? So what I have right now is that I have kilometers at the top of my train tracks and kilometers at the bottom of my train tracks. They cancel out. If I have the same unit at the top and the same unit at the bottom, those units cancel out. So right now, my units are meters. I'm in a unit of meter. I don't want to be in a unit of meter because the question, if you go back to it, it says how many decameters am I in? So I do the same train track. I'm in meters right now because my kilometers were canceled out. And our next conversion is 0.1 meter is 1 decameter. All right, so meters at the top, meters at the bottom, meters cancel out. Now my unit is decameters, and I'm in the right unit. Now to solve this math problem, the last part of the train tracks is that you take everything at the top and multiply it together. And you'll get a number. You take everything at the bottom and you multiply that together separately, and you'll get a second number. I'm going to call that, put a little 2 to show you that they're different numbers. You take these two numbers, you take the top number, you divide it by the bottom number, and that will give you your final answer. So assuming I did my math right, I got 5,150,000 decameters. All right? And that's how you can do any unit conversion. As long as you have the units in front of you, the conversions, you can do that type of conversion. Now, I will post this online, but what I'm going to do is I'm going to give you a second to write this down if you want to write it down. Then I'm going to close out of it, go back to the PowerPoint, and show you how to do E. And I'm going to do that on the PowerPoint so you have something to look at while you try these problems by themselves. Because E is a little more complicated than A is. So let's go back to sharing my PowerPoint. Let's go back to my correct slide. Okay, so question. I got 5,100. So it should be 515 times 1,000. So 515 times 1,000. Gotta get my calculator out. And if I made a mistake, I do not doubt that. I do my calculations at night when I'm tired, and so don't be surprised when you see slight calculation errors. Okay, 515 times 1,000 divided by 0.1. Yeah, should be 5 million. So I'll just type out. So 515 times 1,000. You take that number and you divide it by 0.1. Okay, so let me do E on this PowerPoint so you can see it. So E, train track methods. I got 2.554 milligrams per 1 milliliter. So this is why I wanted to do E, to show you how the train track methods work. You want to think of this middle line as like a division line, right? It's this middle line right here. It's the same line that you see when you see these units split. So what this actually says, it says that for every 2.554 milligrams, I have 1 milliliter. So that's why I put a 1 milliliter at the bottom. All right, so I need to get to grams per liter. So I'm going to convert to grams first. We go to our chart and we find milligram. And I see for every 1 milligram, I have 0.001 grams. My milligrams have canceled out. So right now, my unit is grams per milliliter. I'm not done yet though. I want to get to grams per liter, right? So right now I'm in milliliters and I want to get to liters. So it's the same idea. Here, milliliters are already on the bottom. So I want to put milliliters at the top because I want milliliters to cancel out. And so 1 milliliter is 0.001 liter. Milliliters cancel out. My units are now grams per liter. And when you do the calculation, you take everything at the top, multiply it together, divided by everything on the bottom. And what you actually find out when you do this calculation, it's the same number, 2.554 grams per liter. So milligrams per milliliter is the same unit as grams per liter. All right, so that is the method I use to convert, and you can convert anything in the world as long as you have the conversion factors. So what I want you all to do right now is I want you to get some hands-on experience. I'm going to give you time to try B, C, D, and F. And so I'll give you some minutes to work on that. And then I'll put up the answers next to the questions. And if you have questions while doing this, feel free to send me a private message if you want, and I can respond privately back to you, or just send me, or just send a group message and I'll get back to you then. But at this time, I actually want you to try and work these out. See if you can get the right answers, because now is the time to practice and now is the time to get them wrong. I want you to get them wrong now instead of the test. Yeah, and be careful when you do the calculator stuff. One error I see is that students want to type everything into the calculator at once. And sometimes, and the calculator will follow the order of operations, which may not be correct in the way we actually want it. Well, the way you put it in will give the calculators a different order of operations than what you thought. So just be careful when doing your calculator work. Could you do F, please? I will do F in a minute or in a couple minutes. I wanted to give people like practice about that. Once people have practice, I will put up the answers. But I want you to struggle. And if you're totally lost, feel free to send me a message. Um, if you want to check your answer, feel free to send me a message as well. I will be happy to say you got it right. All right. So there seems to be a couple of you that are a little bit lost. So basically, you can do. I basically want you to try to do them all. If you can. I'm going to stop us here in a little bit. But I will do, let me do B just so that you can see another example of it. Yeah, so I'm going to do like B right at the top. Okay, so B, I want to convert from kilometers to centimeters. So I'll do B and then I'll go and do F again. Okay, B. So I have 515 kilometers. And I want to convert that to centimeters. So if I go over to my chart, I see kilo is right here. And it doesn't matter if we're in meters, grams, whatever. 1 kilometer, 1 kilometer is equal to 1,000 meters. That's how you use this conversion chart. So I go from kilometers to meters, right? So kilometers cancel out. I'm left in meters. But that's not what I want. I want to get to centimeters. And I see centi right here. 1 centimeter equals 0.01 meters. Okay, let's do that conversion. I'm in meters because kilometers have been canceled out. And I see 0.01 meter is 1 centimeter. So my meters, I have a meter at the top, meter at the bottom. They're canceled out. Now what I can do is once you are in the correct unit, you're done putting things in the train tracks. If you're at centimeters, which is what we want for B, we're good to go. So I take everything at the top, multiply it together. I take everything on the bottom and multiply it together separately. Then I take these two numbers and divide them by each other. And what you should get is 51,500,000 centimeters are in 515 kilometers. If for B, you put 1 meter at the bottom and 100 centimeters at the top, that's totally fine. It's the same conversion. Honestly, if I was going to do this by myself, that's what I would do because that's how I memorize. There's 1 meter and 100 centimeters. I'm just trying to keep it with the chart. So you can see what I'm looking at and how I'm doing these. But if you know it a different way, if you know that 1 meter is 1,000 millimeters, it's the same conversion. So do it any way you want to. Yeah. And so I'm going to go through E again. Let me just answer this one message. Then I'll go through E. F. I'm going to go through F so you can see how to do the conversions with the 2 units. Okay, so let's go through F. I'm in kilometers per second, and I want meters per millisecond. So I have 355 kilometers train track. Once I write my first unit, track. Now you see there's second at the bottom. If there's no number, if it's just a whole number, that means there's a 1 at the bottom. Because remember, 355 divided by 1 is 355. So 1 second. And my goal is to get to meters per millisecond. So I need to convert from kilometers to meters. So 1 kilometer is 1,000 meters. So 1 kilometer is 1,000 meters. Kilometers cancel out. So right now, since I had a kilometer at the top, kilometer at the bottom, they're gone. And right now my unit is meters per second. I don't want meters per second. I want meters per millisecond. So I have a second at the bottom. I want seconds to cancel out. And I want to go to milliseconds. Well, there's 0.001 second per millisecond. Again, I'm looking at this milli part. 1 milli equals 0.001. Seconds cancel out. Now I'm in units per meters per millisecond. Take everything at the top, divided by everything at the bottom. And again, I kind of set this up so you get the same answer. 355 meters per millisecond. So for B, it looks like you're off by a factor of 1,000. So that wouldn't count. And I'm just going to answer one more. If you have questions about this, send me a message. Otherwise, I'll go to another example problem that's a little bit more in depth. Yeah, I'll put up the answers right now that I got, and I'll double check them to make sure, like after class, I did all the calculations right. But C, 1, 2, 2, 3, 5, 5 milliseconds. D, I got 1, 2, 2, 3, 5, 5 seconds. Whoops, not grams. Kiloseconds. That's what I want. Yep. So that point. All right. Which makes sense because in D, you should be getting a smaller number. Kilo is bigger than a regular second. C, you should be getting a bigger number. Milli is smaller than second. Yeah, so I will give people just a second to write down what they want. As a reminder, I put the notes I'm looking at on the piece of paper. I put that up. I didn't do it for Monday yet. I'm going to do both of those for Monday and today. Otherwise, this is a very important skill. We're going to be using this skill all through the semester. And like I said, like on Friday, if there's one skill I want you to have that's practical no matter what you do, is unit conversion. So this is a good skill to know for life. So I will go to our next question. And it's another unit conversion problem. So let's see if you got that skill. Now, the distance from the Earth to the Sun is 92,955,807 miles. I want you to tell me how many kilometers that is. And since I don't have the chart up, and not everyone might have the chart in front of them, I will give you the last conversion. Is that 1,000 meters is 1 kilometer. So in all of our previous problems, we always did like a 1-to-1 conversion, grams to kilograms. Here, you need to do multiple conversions to go from miles to kilometers. So I'm going to give everybody a few minutes to do this. I think I'm also going to pop up a poll just to know if you have an answer. So the poll is going to be like, if you have an answer, great. Or if you are 100% lost, great. Those are the two answers to the polls. So let me see if I actually made that. Yeah. Let me just edit that on the fly here. Okay. Okay, so if you have no idea where to start at all, and it feels like you are just completely lost, feel free to answer. I have no idea what I'm doing here. If you're still working, you don't have to answer yet, and just let me know when you do have an answer. Then we work in there. So I just want to gauge where we're at. I'm sure you all don't want to hear me typing, so let me mute myself. Okay, so looks like we have about a third, a little more than a third. Not quite sure how to do it, and I'm going to um, assume the rest of the people who haven't answered. Oh, there we go. Now that I said something, so looks like we're about half. Not quite sure how to go about this. The other half, I'm going to assume, are still working if you haven't put in an answer yet. And so I'll work through this one. Just a minute. I want to give those probably a minute more. Those of you who are still like thinking about this, I don't want to swallow the fun for you. And I forgot to, sorry, everyone, don't need to listen to my typing. Poll never popped up. It says it's in progress. So maybe if you go to the top of the screen, maybe you might have to be like in full screen mode. But if you go to the top of the screen, you should see polls and hopefully it'll be flashing. That's what I heard and some other students say. All right. So that's 4 minutes working on this problem. And hopefully, when it comes to test time, that's all you would need to do a question like that. That's what we're working towards anyway. So you can pop these out in like 3 to 4 minutes. But let me show you how to do this, because it looks like half of us are still kind of stuck. And that's fine. That's what we're here for. We're here to learn how to do this. So let me go to my pen mode. Okay, the overall thing, let me just write what I find useful sometimes when doing a problem is just to rewrite the problem in my own words or just notes about what I'm doing. So I know, and you can see how great of an artist I am, E for Earth. We know this distance in miles, but I want to know what it is in kilometers. So I need to go from miles to kilometers. And without any numbers, we can actually see the path forward based on our conversion. Because I can say, well, I'm in miles. I have a conversion that will get me from miles to feet. If I'm in feet, I have a conversion that I can go from feet to meters. If I'm in meters, I can go from meters to kilometers because that's all in my conversions. I have all the numbers there. So now I'm just going to use my train tracks to do that correctly. To me, the train tracks are great because I know there's no question if I need to multiply or divide something. That's why I use them in my own calculations to this day. Saved me a lot of headache. So I started with 92,955,807 miles. And I'll just say, if you don't like the train track and you have a method and you're getting the right answer with that method, you can throw my method out. I don't care if you do it like me. I care if you get the right answer. All right. So there's my starting point, miles. And I know somewhere along here I want to end in kilometers. So I know 1 mile, miles at the top to start with. So I need miles at the bottom. They cancel out. 1 mile is 5,280 feet. So the only unit I have right now are feet because miles have been canceled out. All right. So now I can go from feet to meters. 1 foot is 0.3048 meters. Feet at the top, feet at the bottom. Right now I'm in meters. That's my unit. All right. 1 step away from kilometers. 1,000 meters is 1 kilometer. Meters at the top, meters at the bottom, they cancel out. So all my units have canceled out. My unit is kilometers, so I'm good to go. Now I just need to calculate. So you take 92,955,807, so this number, multiplied by 5280, multiplied by 0.3048, multiplied by 1. And what I do is once I have my top all in my calculator, I hit enter and I write that number down. Once I have that number, I'm going to divide it by 1 times 1,000. So I'm going to multiply all these together, but they're all ones except the last number. So I'm going to take my top number divided by 1,000. And assuming I got it right, I want 3 sig figs, so I only want 3 numbers. I got 1.50 times 10 to the 8th kilometers. So if you're looking at your, if you have a number and you're not sure, like, is that right? Let me put it out of scientific notation. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 1, 2, 3. So you're looking at like 150 million kilometers. You might have gotten like 149 or something like that. That was just me rounding. But that is how you got. That is how you convert between miles and kilometers using all of those different conversions. So any questions that you might have about that? How do I know when a number goes directly under the number on the trade track rather to the right? All right. So let me answer that. So if I have a unit that's like 20 meters per second, what that actually means is that number is actually 20 meters divided by 1 second. That's what meters per second or miles per hour means. And you actually know this if you drive a car, right? The speed limit in some parts of the Texas highway is 75 miles per hour. What does that mean? That means you can go 75 miles per 1 hour. So in the train tracks, the way I would do that, I would do 20 meters dash or line, then 1 second, and then continue my conversion from there. If it was just 20 meters, I would leave it blank underneath it because there's no unit in the denominator. This is just 20 meters divided by 1. So you could put a 1 there, but it's a 1. It's not going to change any calculation. That's how you know if the number is under it or to the right. And also for like these, these are conversions. So 1 mile equals 5,280 feet. Another way I could write that is for every 1 mile, there's 5,280 feet. So that's the conversion between miles and feet. Or there's 5,280 feet for 1 mile. That might be easier to understand. So for 5,280 feet, there's 1 mile. Since they are, anytime you see like an equal sign like that, that means they are going to be underneath each other on the tracks. That's another shorthand for you. Other questions we have. Can you explain the answer again? Sure, I'll do that super briefly. We started in miles. I went from miles to feet. I used my conversion on the right. So miles cancel out, I'm left in feet. From feet, I went from feet to meters. And so feet cancel out, I'm left in meters. From meters, I went to kilometers, meters to kilometers. I'm using the conversion factors to do that. And so right now I have kilometers. There's no kilometers at the bottom here. So kilometers don't cancel out. So my only unit left are kilometers. And so what you do is you multiply everything at the top together, divided by everything on the bottom. And you should get that number. Can you explain how you went to kilometers and 3 sig figs again? So basically, we're going to talk a lot about sig figs on Friday as well. But let me just see. Some of you told me what your answer was. So if you do this calculation, you get a number that's like 149,597,870, something like that. And I want 3 sig figs. That means I only want these top 3 numbers. So it is 9 followed by a 5. That means I round up. So it becomes this number. And then I just did scientific notation to get a 1.50 times 10 minus 8. But we will talk extensively about that on Friday. So I'm not going to go into that too much on today. Yeah, that's the same how I got the 8 as the exponent. That will be covered for Friday when we go more into sig figs. I probably should have just had the answer and not say 3 sig figs here. I'm writing everything correctly, and then I plug in the calculator and I get something different. Okay, that is a very common problem. When you put it in the calculator, I highly suggest you do the top multiplication first, and you write that number down. Then you multiply everything at the bottom together, write that number down, then divide those 2 numbers. If you do it that way, you will not have any miscalculations. Does it make a difference on what number's on the top? Yes, it does. Makes a big difference. And the way that you do it is whatever you start with, like, so my number here was 92 million miles. That number goes on the top. And from there, I just wanted to cancel out miles. So my next miles had to go on the bottom. If I have a miles at the top, miles at the bottom, they cancel out. Feet to feet, they cancel out. Feet at the top, feet at the bottom. Meters to meters, they cancel out. How will we show our work when we are on a test or a quiz? You probably won't, and I'll probably just look for the answer. So I don't know yet is the short answer, because we are doing training for ProctorU, which I talked about on Friday. So I will let you know when I have more, when I know. I do not know. All the numbers, right? Like all of them together. Yes, so you want to take all the numbers at the top, multiply them together. Then take all the numbers at the bottom and separately multiply them together. Then divide the 2 numbers. All right. No partial credit. Probably not on an online test, unfortunately. That is one of the fun things about doing an online test. I don't know yet, though. That's up in the air. I need to think about that and talk with some other people. Is there more examples of conversion so we can practice? Hey, yes, there are a lot. One, I will be posting and it's about time for class to end, but mastering chemistry in your homework. You will have homework problems that do conversions. So you're going to have hands-on practice right then. Let me get out annotation mode. Question 3. Question 3 is the same thing with conversions, but using density. So what I would do is probably for question 3, I won't do that on Friday unless there's like a mass outcry. And I know all my writing's still there. But question 3 is another unit conversion problem. So I will post the answer online. I'll show you my work online in a document. If you have no idea how I did my work, let me know, and I'll briefly do 3A like on Friday, but that is more practice. You can also do a lot more practice if you like type in online like unit conversion practice. Could you write 150 times 10 to the 6? Yes, that's 150 times 10 to the 6 is the same as 1.50 times 10 to the 6. Kevin, yes, I did. I thought I messaged you back, but just send me an email as class is running out. Is Mastering Chemistry in Pearson right? Yes, Mastering Chemistry is under Tools, Pearson Mastering Chemistry. I forget the exact name, but yes, that is separate. And that's where your like homework due on Sunday is. And so I'll make another announcement. It is not found in the same places as the quizzes and the grades. But that is unfortunately all the time we have here. So if you have questions, still like 100% lost, not sure what to do, of course, email me. Our supplemental instructor, he had some family issues. That's why he wasn't able to make it to class yet. He will also be around to have meetings with you to get help. Also, the Academic Learning Center, tutoring, they can help you with this a lot. I can help you with this a lot one-on-one. So there are resources out there. If you're not quite sure about those resources I just said, email me. Otherwise, practice. Go back to these problems. They're posted online. I'll post the answer sheet online. Try these, and we will work from there. Otherwise, have a good rest of your Wednesday, and I hope to see you all on Friday. Take care.